Okay, AP Chemistry kids, I want to show you an example of how we would do a weak base determination of the pH. It is different than a strong base because the amount of dissociation or production, I would say in this case, of hydroxide ions is not always equal to the initial concentration of the base because it's weak, so it only partially will form hydroxide ions. And remember, I have here that weak means very little dissociation or reaction in water. Very little dissociation, that would be on the acid sense, or that reaction with water would be on the base sense. And so what I want to just kind of let you guys know here is that this is an example of a weak base. And if you watched that earlier video from Renee McCormick, and I hope you did, she kind of went through what bases were. And you'll notice that this compound right here, I'm going to highlight it. That compound right there is a nitrogen. And when you see an organic nitrogen, we call them typically, they're in the amine family, if you remember that part from your organic chemistry. So those are really good things for you to kind of watch out for and know that they are going to be reacting with water. You'll also notice in this reaction, I'm writing the water where in the acid reactions I don't. That's because the water is acting as the acid, and the CH3NH2 in this case will be acting as the base, as you can see from the reaction. I think it might be helpful for us just to go over a little bit, and so I'll try to write out some of this thing, this piece here. But bases like NH3, okay? So a base like NH3 have at least one unshared pair of electrons. So if you were to draw the structure of ammonia, and maybe Renee McCormick went through this already, but it's helpful for kind of take a look at that. That NH3 will react with water, and we can write water kind of more like HOH. So here I'm going to put the double bond oxygens here, and I'm going to put the hydrogen there. And what actually will happen is, let's see if we can get a different color here. What will happen is that this H right here, there will be a break right here in that hydrogen-oxygen bond. So right here is the break in that hydrogen-oxygen bond. And what happens is that H will just plop right there into those two lone pair electrons. And it's called actually a coordinated covalent bond. And it is like the ultimate sharer. It's saying, hey, nitrogen's there. I've got 2 electrons. You hydrogen don't have any. Come on over. I'll let you share both of my electrons. And so what ends up being made here then, go back to black, is that what actually happens to be made when we do this is you're going to end up with something that looks like this, which you guys should identify as the ammonium ion. And what you have left over is the OH. And that OH, that oxygen, or that hydrogen, since just the hydrogen left, remember it's just the H plus that left, it left those 2 extra electrons, and so that's where you end up getting that negative charge. And this, of course, would have that positive charge. So the ammonium ion and the hydroxide ion. So that's how a weak base forms hydroxide ions. And then remember that this dissociation isn't 100%, or this reaction isn't 100%, and that's why, indeed, it's weak, okay? So here you've got a base, and it's a weak base, and we're writing the reaction. We're putting the water in because the water is acting as the acid, and it's asking you to calculate the pH of this base, and they're giving you something called a KB that you'll notice that's right here, okay? Okay, they're giving you a KB, and that KB is related to a Ka. Oh, get down to the pun. So a Ka times a Kb would equal a Kw. And that's an equation that's on your gray sheet. So if they gave you a Ka and you're like, oh, watch out, this is base here, I know this is a base, I'd have to get to a Kb, you can use that equation, Ka times Kb equals Kw. But in this case, they gave you a Kb to work with, which is good. But notice they're asking you to calculate the pH. And pH is hydrogen ion concentration. But in this reaction, what you're making is hydroxide ion concentration. So that's kind of a bit of a tricky thing that you need to just pay attention to. If you're talking about base, notice when you're going to do the Rice table. So here's my equation. And initially, I write out the initial concentration was 1. There is no water, or water is the liquid. So sometimes it's written in the Rice table, but it's like there's nothing that we write in that column because it's not aqueous. But we still have it in there because otherwise you don't know where these OHs are coming from. So as I set up this Rice table, I've got 1.0 molar base, and I'm not allowing anything. The dissociation has not happened, or the reaction has not happened yet. We know that the base is going to get consumed a bit, and we're going to make the cation and the anion. In this case, the anion is the hydroxide. And so I set up my Rice table at my equilibrium line. Now, oops, here we go again. So let's go back to this. I'll kind of move that over to the side. So now the Kb that we were given is equal to this equilibrium line, since it's a Kb because of that OH right there, okay? So the Kb is 4.38 times 10 to the negative fourth. That's going to equal x times x over 1.0 minus x. Solving it the simple way, we're going to say that x is equal to 2.1 times 10 to the negative 2. That's the hydroxide ion concentration. Remember, look at this is probably the most struggling thing that kids have with doing weak base problems. When they're solving for X, they're not recognizing that they're solving for the hydroxide ion concentration. So please, please, please just make sure when you're writing out your Rice tables and you're just making sure you know what X is. Sometimes it's hydrogen, sometimes it will be hydroxide. That's going to help you in the long run for both my test and the AP test. Okay? So now, if I solve for the negative log of X, which is hydroxide, I'm not making a pH, I am creating a POH. And here the POH, as I calculated, is 1.68. To get to the pH, which is what they're asking for, you are then going to subtract that from 14. 14 minus 1.68, which is the POH, will give you the pH, which is 12.32. And that's how you calculate a pH of a weak base. I hope this helps, and good luck.